Okay, so this will be the last video for today, which is a sequences and series question, which I think that Div Dust will find particularly exciting. So let's do question part A. We know that the sum of the first 10 terms is 100. So what I'm going to do is I like to write down my working as much as I can from the question. So the sum of the first 10 terms is 400, and the sum of the next 10 terms is 1,000. So I can't really notate that particularly well, so I'm going to actually just, for now, write this down as the sum of the first 20 terms is 1,400. Because that's what it must be. If the first 10 is 40 and the next 10 by themselves is 1,000, then all up the first 20 terms must be 1,400. So we've been asked to find the common difference, which is D, and the first term, which is A. And what we have now is two different sums at certain points in the sequence. We know that the formula for the sum to a term, any term, is the same as n over 2, 2a minus n minus 1 d. Sorry, plus n minus 1 d. So what we can do now is we can set up two equations. One that equals 400, and that's when n is 10, so 10 over 2, and then 2a plus n minus 1d, and one where the sum is 1,400. That's when n is 20, we can do that, and again we get 2a plus n minus 1d. And of course I can actually put in the n values here. So for this first one here, n is 10, so that actually there would be 9, and here n is 20, so that actually would be 19, like so. And so now I've got two equations with two unknowns, an a and a d, and it just becomes a bit of algebra to rearrange that and solve it. I'm going to do a bit of tidying up first. So what I'm going to do is I'm going to take this, 10 divided by 2 is 5. I'm actually going to divide 400 by 5. And 20 divided by 2 is 10. I'm going to divide 1400 by 10. And that'll help me tidy up part of it. So I'm going to get 80 equals 2a plus 9d. And I'm going to get 140 equals 2a plus 19d. So you might have thought about maybe expanding out these brackets, but actually because it's a multiplication here, you can just divide through and it makes it a whole lot easier. At this stage, hopefully what you can see is that I have got in both expressions 2a. So 2a plus 9d equals 80, 2a plus 19d equals 140. So what I actually can do is eliminate those two a's from each other, and then what I can end up with is that 60 equals 10d, so d equals 6. I think maybe I just did that a little bit too quickly for you. I know we haven't done the elimination method for simultaneous equations for a very long time, but remember it's that whole method where if I have something like 2x plus 4y equals 10, and I have 2x minus 6y equals 4, then I can subtract down between the two systems. So 2x minus 2x is 0, 4 minus 6y is 10y, and 10 minus 4 is 6. So you can actually solve it that way. That's the other way that you can solve simultaneous equations. So I've just used that method here to quickly find out what d was. If you wanted to, you could also rearrange both of these equations, make 2a the subject and then equate them and then rearrange it and so forth. You'll get the same answer. So in this case here, d is 6, and what we need is a. So we can go back and use, let's say this equation here. If I put d in for 6, I get 54. 9 times 6 is 54. If I take 54 away from 18, I'm going to get 26, I believe, which means that a must be 13. So I can write that there. A is 13. Okay, on to part B, which is all about geometric progressions. So for the first geometric progression that we've got, A equals A, R equals R, and the sum to infinity is 6. So if you remember the sum to infinity formula, or you don't have to remember it actually, just look at your formula sheet. It's the same as A over 1 minus R. So in this case here, that means that 6 equals A over 1 minus R for the first progression. For the second progression, the first term is 2A, the ratio is R squared, and this time the sum to infinity is 7. So 7 equals A. Now A in this case is actually 2A, and our R value in this case is R squared. Cool, so now what we've got is two equations with two unknowns, the A and the R, and we're going to have to solve them. And it's another simultaneous equation. It doesn't look immediately like one that we can kind of start going with. We've got to rearrange it first so that we can manipulate it in a way that gives us one equation with just one unknown value. So what I'm going to do is I'm going to multiply out by the denominators of the fractions so that I can kind of start to move things around. So I'm going to do 6 times 1 minus R equals A for that one, and 7 times 1 minus R squared equals 2A for that one. And it would be great if these two were the same values, because then I could equate those sides. They're not quite the same. This is 2A, that's A. Now, you could think, well, if I divide this all by 2, it'll make an A, but if I divide by 2, I'm going to get 7 over 2, which is a fraction. So, although fractions are our friends, sometimes we don't have to hang out with them. So instead what I'm going to do is I'm actually going to multiply this all by 2, which means I'm going to get 12, 1 minus R equals 2A. Okay, now because those both equal 2A, I can equate these equations. Like so. If I expand that out, and then rearrange it, I'm going to get 7R squared, minus 12R plus 5 equals 0, which is nice. It's a quadratic. That's what we're always looking for these questions. So all we have to do now is factorise that into two values. So we know that this middle term is negative, which means that this is positive. So we're going to have to use a -5 and a -1, and they tend to give you prime numbers for this because it makes the combinations that you have to consider to find the right ones smaller, since a prime number only has itself and 1 as factors. And now what we need is the values that multiply to 7 and get them in the right place here. So that is going to be R there and 7R there. If you do a really quick check, R times 7R is 7R squared, R times -5 is -5R, 7R times -1 is -7R, so that together is -12R, and -1 times -5 is 5. So we're done, nearly. That means that R equals 1, okay, or R equals 5/7. So we've found the two values that are possible for R. Well, yeah, for it to be a sum to infinity, your R value has to be between 0 and 1, or it has to be a fraction between 0 and 1. It could be negative as well, but in this case here, we've only got 1 and 5/7, so that one actually doesn't work. If you have an R value of 1, then your geometric progression will just be the same number, and it won't sum to infinity. So for it to sum to infinity, it's got to converge, which means that your R value has to be between 0 and 1. On the formula sheet, you'll see R with two lines either side of it. That means the absolute value of R. So -1/3 is fine, and 1/3 is fine, but it's got to be between 0 and 1, or 0 and -1. But it can't be 0, and it can't be 1, and it can't be -1. Yeah, hopefully that makes sense. So that means R actually can only be 5/7, and if we know what R is, then we can use our equations here to work out what A is. So if I was to use this equation here, for example, I know that 6 equals A over 1 minus 5/7, which is 2/7. And if you do that on your calculator, so 6 times 2/7, you will get an answer of 12/7. And we're done.